All right, so like I said, we're going to be learning some trigonometry today. As a last reminder, if I put you next to your favorite person in the whole world, it would be very intelligent of you to at least wait a week to start talking to them, so I don't split you up, Mr. Magden. So, you're welcome, for those of you that are enjoying your seats, and if you're not, and again, if you have complaints like, they ugly, come see me after school and we can work that out. I can't make them less ugly, but I will try to make them so they're not in your vision. So, we're going to learn about trigonometry today, and trigonometry starts with this little prefix, try. Try, as in you need to try it and not give up. Today's going to be a little intimidating. We're going to do a little Greek letters for the first time ever, which is exciting. They're no big deal. You just got to try. Try also means triangle, right? So we're going to be studying these triangles and how they relate to each other. So what we're going to do is we're going to break down these triangles into specific kinds, right? The biggest triangle, the most famous of all, is the right triangle. And you know there's Pythagorean theorem that helps you find all the sides, right? A squared plus b squared equals c squared, yada, yada, yada. It turns out that there's also this relationship between the angles and the side lengths. So, for instance, if I've got a bunch of lengths here, let's have this be 3. Do not roll. Let's have this be 3 as well. And if I connect them up like so, and then I have, I don't know, maybe 2 on the bottom. You'll notice that when I make this triangle, we've got 3 angles, and these angles are well defined, right? They have a certain measure. There's no other thing that they could be. If I change the length of some of these sides, like I make this 1 and, I don't know, make this 4, I have something that doesn't work as a triangle because I'm a dummy. Let's do 3, 3, and 1. We get different angles. So the sides help determine the angles. So there's a relationship there. The angles, on the other hand, do not determine the sides. They might determine some kind of relationship, but they don't determine the exact length. So for instance, if I had a triangle like this, it's an equilateral triangle. All the angles, therefore, are 60, right? They're all equal. If I increase the side lengths, right, to 2 on each side, it would still be equilateral, which means my angles would also all be equal, meaning that they're all 60 degrees. So the angles themselves don't tell you much about the side length, right? They might tell you the relationship, hey, they're all the same sides. But you don't know how long they are, right? If I told you, hey, I've got a triangle, it's equilateral, it has all of the angles 60, 60, 60. How long are the sides? Well, I mean, I don't know, right? It could be anything. If I tell you one of the sides is also 5, well, then you know, oh, well, all 3 sides are 5 because it's equilateral. But just the angles alone is not enough to tell you side lengths. So in general, the angles do not imply the sides, but the sides do imply the angles. There's a relationship there. So if we know the sides, we can find the angles. And there is a way to do this as well. It's just a little bit more complicated. So let's get down to what exactly I'm talking about. Here's a right triangle. And we're going to learn about our first Greek letter. This Greek letter is theta. And the symbol for theta, which I can draw better if I draw it big, is just a circle with a little Pepsi symbol, right? It's got the little swirl thing. Everybody loves Beppis, right? So there's the Pepsi symbol. We call this theta. We spell it like this. It is a Greek letter. And we use letters in math to represent variables, right? It's something we don't know, like x or y or z. And when we use x, x can be used for anything, right? What's the length of the side? Oh, it's length x. Or this equation is 2x plus 1 equals, I don't know, 5, right? X could be anything. Theta can be anything as well. It's just variable. The difference here is that theta is usually used, almost always used, when we're talking about angle degree. So we're talking about some kind of angle measure, right? So whenever you see theta, you know it's some unknown number. What is that number? Well, it's some kind of degree measure, some kind of angle measure. You're going to learn later that there's other ways to measure angles called radians. But in general, we use degrees, especially in here. You'll learn more in trigonometry when you take the actual class about radians, and they are so much better than degrees. They're weird looking, but they're so much better. So this is a Greek symbol, theta, and it means angle measure. So this symbol right here is saying, hey, that angle measure is x, right? We don't know what it is. It's some variable. So I could tell you maybe that, like, theta equals 30 degrees, right? That's possible. That's what that symbol means. Theta, or Theta as she went by, was my Sunday school teacher when I was much younger, and apparently Miss Snyder had her as a teacher at Plano High School or middle school or I don't know, elementary school. She's a very nice lady, and I always think of her whenever I write this. I don't know why. Probably because her name looks a lot like that. Shout out to Theta, who is very, very old. I'm pretty sure she's still alive. Shout out to you. Like and subscribe. All right, so theta is an angle measure that we don't know. Okay? Now, how does that angle measure relate to its sides? Well, I'm going to tell you this. If I say that this triangle is a 2, 3, 5 right triangle, which is a real right triangle, 2 squared plus 3 squared does equal 5 squared, then theta can tell us something about these side lengths. So here's how it works. You probably have heard of this. I hope you have. Who's ever heard of sine? I'm going to regret using this color, but whatever. Cosine. And we'll do it in this color. Oh, no, let's use it. Yeah, good color. Good job, Mr. Brad. Tangent. Oh, yeah, this is the one marker that writes pink, even though it's purple. All right. Who's ever heard of these three things? Sine, cosine, and tangent. Sort of. You might remember tangent from last semester when we talked about a circle, right? A line that just kisses that circle is tangent. So I'm going to draw that up on the board. It's not really related to what we're doing today, 100%, so I'm not going to talk about it too much. But tangent means you've got a circle, and at one specific point, that's where the line touches. That line is tangent to the circle. You might remember that. It also has something to do with triangles, which is related to that a little bit. These are the three big guys that you're going to have to remember, though. Sine, cosine, and tangent. And what are they? Well, they're operations. They're things we do to numbers and stuff. So, like, for instance, here's an operation. You've probably heard of it. Plus. Its opposite is subtraction, minus, right? We also know some other operations, like multiply. And what's its opposite? Division, divide, right? We know about taking a number and squaring it. What's the opposite of that? Square rooting it, right? And now we're going to learn about trig functions. Okay, all of the above, we call this arithmetic. Because it is arithmetic. It is something that you would do in elementary school. It's elementary school math, or middle school if you really want to do it, expand, right? Trig is the beginning of new kinds of math, okay? It's going to be new things that we do to numbers. So trig functions are these guys, sine, cosine, and tangent. So how they work is this. Sine is abbreviated sin because, I don't know, it's just who would want to write that E? That's awful. And then we do sine to an angle measure. So it's something you do to an angle measure. Cosine is abbreviated COS, cos, or cos. And you do it as well to an angle measure. Same thing with tangent. We abbreviate it tangent because we're so creative in the math field. And yes, there are a lot of math jokes. So we have sine of theta, cosine of theta, and tan of theta. Another way to do it would be to write x here. That works too. But we know that it has to be an angle measure. So that's why I use theta. Okay? So what are these things? How do we know what they are? How do we translate them? They're Greek. This is gross looking. It's very easy. There's a mnemonic that you can use to help you out. And before I get there, let me give you an example of what this is. So sine of theta. Here's theta, right? Oh, I'll see you after lunch. All right, I'll give you a spot first. Yeah, I got to